All right, today we're diving into something that sounds, well, kind of crazy. What if a drug that millions of people take for depression could actually be a secret weapon in the fight against cancer? It's a link that nobody, and I mean nobody, saw coming, and it might just change, well, everything.
So let's just get right to it with the big question. Can a drug meant for depression really truly fight cancer? I know, it sounds like something straight out of science fiction, right? But stick with me, because the science here is absolutely real, and it is fascinating.
Okay, so the whole thing really comes down to this totally unexpected connection between what's happening in our brains and how our bodies fight off disease. The best way to think about this is like a detective story. We're going to follow the clues, piece by piece, to uncover this hidden mechanism that, honestly, it could completely change the game for cancer treatment.
All right, every good story needs its heroes and villains, right? So let's meet our cast. In this corner, the good guys, your CD8 T cells. These are the absolute elite special forces of your immune system. Their whole job is to hunt down and destroy threats, especially cancer. And in the other corner are villains, the tumors. And these guys are clever. They're masters of disguise who've learned how to go invisible to our immune system soldiers. And that right there brings us to the heart of the mystery. See, scientists have known for a while that tumors don't just play defense by hiding. No, they actively fight back. It's like they've figured out how to disarm our T cells, flipping some kind of secret off switch that just shuts down our body's best defenders.
So, you're probably asking, how in the world do they do that? Well, they exploit something in our own bodies called an immune checkpoint. Now, these checkpoints are actually a good thing, normally. They're like natural brakes on your immune system, keeping it from going haywire and attacking healthy cells. But here's the sinister part. Tumors have figured out how to hijack this system. They basically slam on those brakes, bringing our T-cell attack to a screeching halt.
So researchers are trying to figure out how to release these brakes, right? And in the process, they stumble onto a really surprising suspect, a protein that, frankly, had no business being at the scene of the crime. It's called SIRT, which stands for the serotonin transporter. So let's get a profile on this suspect, SIRT. What do we know about it? Well, its day job is pretty famous. It works in the brain, managing our feel-good chemical, serotonin. In fact, it's the main thing that common antidepressants, SSRIs, go after. So the million-dollar question for these scientists was, what on earth is this brain protein doing hanging out on T cells inside a tumor?
And that strange clue led them to this really radical idea. Could SIRT be the secret weapon? Could this be the hidden off switch that tumors were using to power down our immune system's best soldiers? Well, if you have a hypothesis like that, there's a really obvious way to test it, right? If SIRT is the off switch, then a drug that blocks SIRT should, in theory, release those brakes and let the T cells get back to doing their job. And the crazy thing is, those drugs already exist. They're all over the place. We call them SSRIs. So that's exactly what they did. They set up the experiment. They took mice that had some pretty aggressive cancers. We're talking melanoma, colon cancer, breast cancer, and they gave them a really common SSRI, fluoxetine, which you might know as Prozac. The whole point was to see if blocking this SIRT protein in a real living animal could actually make a difference and slow these tumors down.
And the results? They were absolutely stunning. I mean, look at this. This chart is basically the smoking gun of the whole investigation. The mice that got the SSRI treatment, their tumors barely grew compared to the others. The difference isn't just noticeable, it's massive. It's a huge deal.
The conclusion was just unavoidable. Giving these mice an antidepressant didn't just slow down the tumor, it actually helped them live longer. At this point, that crazy hypothesis, it was starting to look really, really strong. Okay, so it works, great. But why? How is this actually happening? Seeing that two things are connected is one thing, but the real breakthrough is figuring out the mechanism. So the next phase of the investigation was all about cracking that code. How exactly is an antidepressant supercharging these T cells? And this is where the story gets even cooler. What the researchers found is that T cells don't wait for serotonin signals from the brain. No way! They make and use their own serotonin right there on the battlefield, inside the tumor. It's like their own personal energy drink, a little hype signal to get themselves totally pumped up for the fight. So let me break it down. It's basically a three-step process. Step 1. The T cell releases its own serotonin to get hyped for battle. Think of it as hitting the go button. Step 2. That pesky SIRT protein shows up and acts like a tiny vacuum cleaner, sucking up all that serotonin to calm the T cell back down. That's our off switch. And then Step 3. The SSRI comes in and physically plugs up the vacuum.
With the vacuum blocked, all that serotonin fuel stays around, keeping the T cell in full-on attack mode.
And you might be thinking, don't we already have drugs that help T cells? Yes, but this is why this is such a big deal. It's a totally different tool. See, current immunotherapies, they mostly work by trying to revive T cells that are already completely exhausted and burned out. But this SSRI trick, it works on T cells that are still active, basically keeping them supercharged so they never get exhausted in the first place. It's a completely different strategy, a whole new angle of attack.
And if you thought that was cool, check this out. When they tried combining the antidepressant with the existing immunotherapy drugs, the result wasn't just additive. It wasn't 1 + 1 = 2. It was synergistic. It was like 1 + 1 = 4 or 5. The two drugs together were way more powerful at killing tumors than either one was by itself.
Okay, this is all amazing in lab mice, but let's be real. The billion-dollar question is always the same. Does this actually matter for people? The final step in this whole detective story was to see if they could connect the dots from the lab back to human patients.
So first thing they did was look at T cells taken directly from human tumors. And what they found was that SIRT, our little off switch, was most active on a very specific kind of T cell, a type called TEMRA cells. Now these aren't your average grunts. TEMRA cells are the grizzled veterans, the most powerful killer T cells in our entire arsenal. So the tumors weren't just disarming soldiers, they were specifically targeting our special forces.
And then came the final, most powerful piece of evidence. They looked at data from actual human cancer patients, and the connection was chillingly clear. The more of this SERT off-switch protein a patient had in their tumor, the worse their survival rate was. This was the proof. This wasn't just some weird thing happening in mice. It has very real life-or-death consequences for people.
So where does this leave us? What's the final verdict on all this? And maybe more importantly, what does this mean for the future of fighting cancer?
Well, the researchers themselves put it pretty plainly. Their conclusion is that SIRT is, officially, a new kind of immune checkpoint. It's a brake on our immune system that we never knew about before, one that tumors have secretly been exploiting all along. So let's just boil it all down. The final verdict is this. 1, there's a new immune checkpoint out there called SIRT. 2, we have common everyday antidepressants that can block it. 3, blocking it seems to turbocharge our immune system's ability to fight cancer. And 4, this opens up a whole new playbook for developing immunotherapies, especially by combining them with the treatments we already have.
It really is just an incredible story of scientific detective work, isn't it? And it just has to leave you wondering, if a simple antidepressant was hiding this kind of power, what other incredible secrets are just sitting there, hiding in plain sight, right in our medicine cabinets?